what we are trying to solve is how can we make fresh water with renewable energy. And so this is where we came to a solution that uses the energy and the resources at the exact same spot, which is the ocean. So there's a lot of energy in the ocean. You just need to capture it. Waves are super strong, and so this is what we do. We capture the energy from the waves, and we use that energy to produce fresh water out of salt water.
The goal of the Wave to Water Prize is to create solutions that make fresh water right from the ocean using only wave energy for the entire process. The main reason being is that if there's a catastrophe like a hurricane or an earthquake, you need water to be brought quickly to those locations where the infrastructure is broken. And the current solutions in place, whether it's like shipping bottles or other fuel-powered desalination, can have their limitations.
We had about, I think, 66 entrants in the first stage of the prize, and then, as of course over time we've, narrowed that down and got down to what is essentially the final four, which are, four, I think, very fantastic teams who have put a lot of effort into this over the last 3 years and built very interesting technologies. And, so I think, this is something I've been telling a lot of people. Regardless of who wins the grand prize, every technology that's made it to this point has won something. They have demonstrated that they can build a functioning, meaningful technology, and I think that's, if nothing else, we've been able to show that with this.
Instead of using fuel, which is normally used to run generators, then electrical motors that run pumps to bring the seawater high pressure, Oneka eliminates all those components and directly uses the waves as a pump to pump the seawater through reverse osmosis membranes. This way, we have a very simple and elegant system that directly converts the seawater through reverse osmosis membranes into fresh water. And by doing it this way, we eliminate all greenhouse gas emissions. It can be affordable because it's so simple and it doesn't require any fuel. And normally, almost half the cost is just for the energy and the fuel to power desalination. And in addition to that, there's also a number of environmental benefits compared to conventional desalination that will facilitate the adoption. Namely, we have a low concentration diffuse brine, we use the systems as artificial reefs, and we don't even use any land space on the ground. And furthermore, it's not even grid connected, so it's totally independent from the local electrical supply.
One of the best thing that happened in the competition is just to meet all those people involved into getting the wave energy to the industry. So meeting all the person from the Enroll and WPTO and the other competitor and from the Coastal Study Institute, it was very, nourishing to get all the feedback from other people trying to do what you're doing. So, and see other concept was, I think, it changed how I see me in this old system and a part of, an actor and getting this technology to a point where people can really enjoy it and make a difference in their life. So,
wave-powered desal is still fairly new, so I think it's somewhat natural. I think the argument's understood, but the technology needs to be more proven. I think marine energy too. It's still an early stage at some level commercial technology. So I think that's really why we haven't seen it similar to other renewables, but I think we'll get there. And I think I think desal is specifically one area we'll see that happen sooner than others.
we've done what we were trying to do with this prize. Now, with that being said, we're scratching the surface on wave-powered desalination. There's a whole lot of work that still needs to be done. There's a whole lot of research that we plan on doing at the labs that will be, the Department of Energy will likely be funding for other groups and industry partners, and really just trying to get the whole community moving forward. And I would expect in the next decade or so that you'll see a lot of changes in this space.
Over the years, we honed our skills in deploying those systems that are constrained to really heavily cyclical loads all the time, and everything, like we say, the devil is in the details, and that's like extremely the case in this situation. With time, you're able to see all those little details that make this possible, and it's something that we realized throughout the competition that was really useful, that we had all that background experience to enable us to see all those details that are kind of invisible the first time.
One thing is really opening up the community of problem solvers. There's sort of less restrictions, or it's easier to apply into a prize. Also, there's not really a community around this issue, so wanting to grow, just get a variety of people in there and really think about how to support people in trying to solve these difficult technical challenges. And I also think it helps build excitement and public interest in the area that more traditional funding opportunities don't. So we want devices that go to as many type of coastal locations as possible, and in theory use any sort of infrastructure available to them. So we also knew that this was something the devices should be designed for.
The competition was really interesting in a way that, with all the constraint, it led us to, challenge our own design, and it brought us somewhere better. One of the big constraints is getting the device in this box, so getting everything in the box got us to think outside the box, which is kind of nice, a nice figure to it.
One of the big motivators here is, when we were first planning this, there was, hurricane after hurricane hitting Puerto Rico, hitting Texas, hitting all over the world. We were constantly seeing water shortage challenges. Additionally, at the same time, the Department of Energy was starting to push focus away from just massive scale, utility generation type technologies, and starting to look at some of these smaller technologies. And I think that's really been what's been enabling this prize to be successful and enabling us to do something of this magnitude, really.
When we first set out to do this, one of our motivations was trying to attract new people, new organizations to wave energy. And if you look at the companies that are here today, the companies, entrepreneurs, technologists, it's representative of the types of applicants we wanted at the beginning. I think it shows about the power of what prizes can do, but I think it shows that once you change the parameters of what you're trying to incentivize by changing it from make the best wave energy device from a hydrodynamic perspective to one that really could deliver something meaningful and not just power. I think this prize already has shown that we can do that. I think it's the best outcome that I could have hoped for.
This technology is applicable to all kind of end user. It can be really small communities to like big cities. Main thing they have to have in common is be close to the ocean, but most of the population in the world lives by the coast. So we have a really nice fit between where people live and where our technology is applicable. So it makes total sense to use the ocean as a source of energy to produce fresh water.
Really, a lot of R&D went into wind and solar back in the 70s, and so it's really only been the last decade that we've seen more concerted efforts for marine energy. So I think it's still in its nascency, but I think it's because people look out at that ocean and think that's a source that we should capture. But then if you throw anything into the ocean and you see what comes out, I think it makes people shy away. But that's where I'm really excited about the fact that we're proving both through this prize and through other work that marine energy isn't just something that we can have on paper, but it's something we can actually do in the real world.
It was very interesting to go through all the stages of those competition, and looking back, how the design can change from one phase to another. And there's only 6 months between, so it was really like a way of accelerating the development of a wave energy converting device. So this is a really nice point of this competition, is to push us, the companies, to bring a product that is really compact but innovative in the same time to this event that is a competition.
Water is really essential for life. It's essential for humanity to prosper. Because we just opened a tap, and for most of us, we get water. But that reality isn't quite true everywhere. And the other thing is, we're actually coming to an end of this easy access to fresh water. So what happens with all the population gathering along the coast, concentrating and using more and more water, it's becoming scarce. But also some of the resources are being contaminated with seawater infiltration. Most of desalination today is done by reverse osmosis membranes, which are sort of salt filters. Previously, it was done through distillation, or different ways to distillate seawater. So you can imagine, like, boiling seawater to collect the vapor is extremely expensive and requires a lot of energy. But even today, with very efficient desalination membranes that use essentially pressure to do a similar desalination process, it's still extremely energy intensive.
There were some changes. I think some of the competitors have really evolved and made changes even that we weren't expecting at times. I am pretty amazed at the variety of devices we have, and I'm really interested to see how we set certain rules. We really did see very different takes on it. So that has been great to see, and I think it does kind of is what we were hoping for, but I don't know if we could necessarily expect that. But yeah, the 4 finalists we have here right now, it's really kind of tremendous how different they are, and how much we can learn from each device.
I think all the eye moments have something in common, and it's when you see it working, you know. Sometimes it's only a power output that you see when you install it. It's a prototype, and install it out at sea, and you see it's making 60 watt of power, and you know what it means in terms of reverse osmosis water, you know. And of course, one of the highlights is when we were on Genetsphere and just activated the system, and we could drink the water from the hose. It was, an accomplishment of so much work.
If you look at some of the designs that came through this, the robustness is evident. I still think that, the sun doesn't always shine, and the wind doesn't always blow, and water is always going to be increasingly more scarce, and we're only going to have more climate-related disaster scenarios. And so we have to figure out how to produce clean water for people. And I genuinely think that it's going to work. When, where, at what size? I guess we're all in for that journey together, but I genuinely think that this is both an interesting, promising area and one that actually is a societal need.
For the entire team, spending those 3 years of hard work, combining our multidisciplinary experiences together and successfully make a system that makes fresh water right from the ocean and bring it to the coast within that same prize is incredible. We won a total of almost over $1 million worth of prizes through all the different steps, and the recognition of being the grand prize winner is extremely valuable for us as we're preparing the next steps for this technology. The unit that we used during the competition, Snowflake, we're actually adapting this system to be more optimized for emergency relief applications. And that unit will be called Ice Cube in this new commercial form. And with that device, we'll be working with different organizations to prepare it and make sure it can be deployed quickly to provide water in really critical situations.
I think seeing desalination at this scale will continue and there'll be more of it in the future. Also considering issues around water scarcity. There's so many areas of the world where this would be very beneficial. And I do think wave-powered desal will play a part in that. I think we have some challenges we still have to face, but I could see us working devices in the next couple of years, and I think this is a really good start to getting there.
I feel like it's going to change everything from, getting from a prototype to something commercial that can be deployed all around the world because of that kind of recognition. So it's a game changer.
We are constantly growing as a company. We have a really ambitious mission, a big goal. And for anybody that is passionate, that wants to make a difference, there's plenty of roles, not only in engineering, but either business development, financing, anything you think of that can help build this company. So don't hesitate to reach out to us, and we'll be glad to see how we can work together.